Hello, everybody, and welcome to this Pivot 2023 session, where we're going to be talking today with a number of experts on the drilling and construction of wells, with particular regard, of course, to geothermal wells. My name's John Clegg. I'm Chief Technology Officer for Hephae Energy Technology, company building drilling and measurement tools for geothermal wells. I'm joined today by Cindy Taff, who's the CEO of Sage Geosystems, by Clinton Moss, who is CEO of Gunnar Energy Services. We've got Sarah Jewett here, who is the VP of Strategy for Fervo Energy. And we're also hoping to be joined by Sam Abraham, who's Vice President of Geothermal Resource Group, Inc. Sam is currently kind of stuck in some kind of Zoom limbo. He's trying to call in from the Philippines, and he's got some technical issues. And we're hoping that Sam will be able to join us sometime during the call. My background is in directional drilling and measurement. And in the oil and gas industry, I waged a campaign over the last few years to try and persuade people about the importance of accuracy of wellbore construction, drilling smooth, accurate wells and taking maybe a little bit more time to drill the wells in order to make them more productive. And I think some of that will flow from oil and gas into geothermal. So that's kind of my angle for moderating this session, was to try and get one or two of those points across. But we have experts with us on drilling of wells, on directional drilling and measurement, and also on fracking and stimulation. And so what I'm going to do is pose each of the panelists with us a bit of a question and ask them to kind of answer that question and introduce themselves a little bit at the same time. And the question is, from your perspective, and explain what your perspective is, what do you think will be the key differences between oil and gas and geothermal well designs? And I'm going to start with Sarah. So Sarah, what do you think is going to be the key differences between oil and gas and geothermal well designs? And take a moment to give us a bit of your background as well.
Excellent. I love to go first so I can be shown up by my fellow panelists. I'm the VP of Strategy of Fervo Energy. Thank you all for having me, John. Thanks for moderating. I am in a position where I've been with Fervo for 3 years now, so I've actually seen all of the wells we've drilled to date. For those of you who don't know us, we are a geothermal utility scale power developer, and I'm very proud to say that we're currently drilling our 6th well. We have drilled 2 vertical wells, and this is our 4th horizontal well. So we do have some experience landing and designing wells in geothermal reservoirs. We are an EGS developer, Enhanced Geothermal Systems. So we're typically trying to access the lower permeability systems with horizontal drilling and multi-stage completion. So that's a little bit of an intro about Fervo. And so my perspective really comes from that world. I think, from my perspective, I think in terms of well design, the fundamentals are in large part the same between oil and gas drilling and geothermal drilling. You're still sort of reacting to the same physics overall when you're thinking about well design. There are just some questions with, pressure and temperature differential that may influence some of your well designs and some of the things you end up doing. You may end up thinking about a difference in casing or a difference in, how many casing strings you have based on your potential expected losses, those types of things. But I do think it is a pretty transferable thing when you have experience designing wells for the oil and gas industry to transition those to geothermal. It's more of a tweaking than it is, something that's entirely different.
That's good to hear. Thanks. It's good that we can leverage a lot of that experience. And so now I'm going to let Clinton introduce himself. And the same question, and give the same answer if you want. But are there differences between oil and gas and geothermal well designs? And if so, what are they? So Clinton, the floor is yours.
Sure. Thank you very much, John. My name is Clinton Moss. I'm with Gunnar Energy Services. I'm the CEO of Gunnar. Gunnar develops from scratch, from the back of a napkin right through to delivery of service at the wellhead, ranging instruments. And our primary business, of course, is associated with relative wellbore positioning. So magnetic ranging is used for those to put two wellbores in close proximity or to intersect them, or whatever the case may be. Of course, though, a part of that relative wellbore positioning is understanding your absolute wellbore positioning. So I have a lot of background in, directional drilling, magnetics in general, challenges that we see when we're trying to execute these projects. The main differences that I see, obviously, is temperature. While you can come up against some very high operating limits for oil and gas, we're obviously pushing the boundaries here with geothermal, because I think, generally speaking, hotter is better in terms of energy production. So obviously that's a key difference. But also, we're drilling in formations now that we don't have a lot of data. So, for example, we have millions of miles drilled through shale in various basins in the United States, but we do not have millions of miles drilled through what some people refer to as a basement rock, or more mature, geologically mature formations. And those formations are expected, or could react differently in terms of drilling dynamics, your BHA design, construction, what bits you pick, what your minimum time between failures are as a result. So I think that there's some learning to do, but absolutely agree with Sarah that we leverage our existing techniques, methods from the oil and gas space to hit the ground running, as they say, and have a real head start on our journey towards geothermal energy production.
That's good. So sort of violent agreement at the moment, which I guess is good. I like to just formally introduce Sam. Sam, it's great to see you. I'm glad you managed to get past your sort of technical Zoom issues. Sam, as I mentioned, is the VP of the Geothermal Resource Group, Inc., joining us from, I think, Manila in the Philippines, where it's very late, so appreciate that. What I'm doing, Sam, is just opening by letting the panelists introduce themselves and answer a question at the same time, which is about the key differences between oil and gas and geothermal well designs. So what do you think about that? I'll let Cindy introduce herself and answer the question, and then Sam, I'll come to you afterwards.
Thank you.
Cindy, over to you.
Yeah, thanks, John. Great to be here. I'm excited to be on the panel with my esteemed colleagues. So Cindy Taff with Sage Geosystems. My background is also oil and gas. So I was at Shell for 35 years. My last role at Shell was vice president over their global unconventional wells operations. And yeah, I have to agree with Clinton and Sarah that there are differences, but there's also similarities between geothermal and oil and gas. So differences, I think the one that comes to mind for me are the larger wellbore sizes. So for geothermal, you need huge mass flow rates to get that heat to surface and to get enough heat so that you can be commercial. And so a typical wellbore size down to TD is 9 5/8. You also need larger wellhead bore sizes, so similar to what offshore wellheads. But the similarities are a lot as well. The techno-economic value that you target from these wells is going to be very important, just like it is in oil and gas. So we have to make sure that we're able to drill these wells cheaply enough so that we can deliver energy at a cost point that is competitive with other sources of energy, including oil and gas and wind and solar.
Thank you, Cindy. And now, Sam, I'll let you, pitch you in just after you join the call, but I'll let you introduce yourself and maybe reflect on that same question.
Thank you. Thank you to the Pivot team and everybody there. Good to be with the other folks on Cindy and everybody who I know. Glad to join this talk also, especially discussion-wise. My background comes from being in the oil and gas, deep water, high pressure, high temperature for about 10 years, offshore, especially in the Gulf of, especially Indonesian waters. And then from there on, moving across to geothermal, starting even to the point of Hawaii, drilling in Hawaii being one of the most challenging ones, and other places in the world. So just to answer a couple of those points that Clinton and Cindy did touch upon, one of the things that I see across the main difference between oil and gas and geothermal is that higher temperature in these wells causes a difference in changes in the pressure ratings of equipment used. number one. Number two is, Cindy was mentioning, we are drilling bigger hole sizes. Their hole cleaning becomes a very critical point. If you do not clean your holes properly, then you are starting to get things like tight hole conditions, which escalates up to almost fishing, and that becomes a bigger problem. And the last of all is, especially equipments that we use, like directional drilling tools, drilling bits, have to endure this higher temperature that it's sea, and that makes the biggest difference. Thank you.
Thank you. That's yeah. Great. Thanks everybody. Great introduction there. And I guess I'll jump into. We talked. I guess we touched a little bit on some of the technical design challenges, and maybe we'll come back to those later if there is if there's time, and hopefully there will be. What are the things that we need to consider in order to maximize the output from the well, and to maximize the economics of the well in terms of well design and construction when we're looking both at conventional and unconventional geothermal wells? So the key considerations, if you like, were the most important things to maximize either the power output or the economics, and I think there's going to be a relationship between those two. So Cindy, I'll throw this one to you first in the interest of mixing things up a bit.
Yeah, so I guess simply first would be the heat that you can access. As Sarah mentioned, at Sage, we are targeting hot, dry rock and using enhanced geothermal systems to do so. So if you can access higher temperatures at more shallow depths, then you're going to have a better economic success. And then again, it's related to the flow rate that you can get out of the well, and that's related to the size of the casing that you can put in the wellbore. So we've got a what we call a single well EGS design, where we're actually cycling water in and out of a well versus going between multiple wells. So I would say for our well design, that's going to be the most prominent, would again be the bottom hole temperature that you can access. And we're targeting 150 degrees C or greater, which is 300 degrees F. But if we can drill and get, 200, 220 degrees C, then that would be beautiful. So when I think about the, directional drilling tools that the oil and gas industry offers now, I think the highest temperature ratings like 385 degrees F, which is around 200 degrees C, but then you can have some cooling aspects from your mud. Then I think, we can really drill most of the wells that we are looking for with the current equipment that's available. So now it becomes, how do we get the cost down for that equipment, and then also get the cost down at scale for or by drilling multiple wells on a single pad.
Okay, that's very helpful. Thanks. I'm gonna now I'll go back to you, Clinton. Same question. What do you think we need to consider to maximize well output?
Right. So from my perspective, I've been coming at this with closed loop geothermal systems, and my involvement has been looking into actually connecting up the wellbore. So wellbore positioning is a big deal, obviously, but even where we're trying to stimulate and achieve hydraulic communication between two wellbores, there may be, and other panelists can weigh in, some benefit to having the wells very closely positioned, or within their ellipsoids of uncertainty. What a lot of people don't understand, I'm sure my panelists I'm sure do, but just for the general audience, is that when we drill these wells and we have a plan and we say, okay, the well is in some position and we assign it a downhole coordinate, there's uncertainty associated with that. So in fact, if we think that the well has a certain northing and easting, that could vary by dozens of feet or meters. So in the case of certainly cannot be tolerated if you want to physically connect both wells. Okay, so wellbore placement is critical for that reason. If we want to achieve hydraulic communication by various methods, often it depends on relative and absolute wellbore placement. So to achieve efficiency then, in particular for a closed loop geothermal system, for example, we must constrain, the growth of these ellipsoids, have a better understanding of where our wells are positioned, and then ultimately use relative wellbore techniques, that's magnetic ranging, to have the two wells intersect. So making those processes efficient, cost-effective, routine, okay, is what's going to be critical, in particular for any geothermal system that relies on wellbore placement. And yeah, humbly I submit that most, probably not Cindy's, because that's a single wellbore, but most could likely benefit from a detailed analysis of the aforementioned.
Okay, thanks. And Sarah, I'll come back to you in a moment. I'm going to pitch this one to Sam next. And Sam, what things do you think that we should consider, both in conventional, because I know you've got a lot of experience in conventional geothermal, and in unconventional EGS and AGS wells, to maximize output?
Especially when we're talking of unconventional wells, when we talk about how do you maximize output, you are maximizing your output would be best to intersect the zones that you want, especially also that applies to even unconventional or EGS, where because you are looking for the most output or influx from the formation that you can get. To ensure that, you will have to make sure your wells are positioned properly. I totally agree with Clinton. And again, the other thing would be is how do you allow these wells to flow to surface with maintaining that same enthalpy as it goes along? So it comes again to things like, having the best flow rates. Sometimes when we drill conventional wells, we do not get returns. We have loss of returns. In that case, you do not want to have the expensive jewelry of directional drilling tools, which are probably $1 million to $2 million in your wellbore at that point. So many times, our critical path also comes in that we have to reach our desired wellbore plan before we reach the final production hole, where at that point, we are normally just maintaining our whole direction or letting it slip down as an S shape to just get to the target that we want. But that's what I see all around is that, those tools nowadays, as Cindy was mentioning also, is that the temperature limits are there, but we can manage those very well with even surface equipments that we have, like mud coolers. For example, in Hawaii, we sometimes have used 3 mud coolers, which is effective in maintaining the temperature and helping us to keep drilling ahead. Thank you.
Okay, and thanks. And Sarah, I know that wellbore positioning was, from what I read, it was pretty important to the wells that you drilled recently. So I guess the completion was a big part of that as well. So I guess question for you is the same question, but maybe you'll bring a couple of different insights. And one supplementary question that already came in: your particular well that you drilled, was that in sedimentary or basement rocks, or was it a mix of the two?
Yes. So let's talk about our Utah system right now. The Nevada project that we talked about in July was simply a 2-well horizontal system, and that's all that it was intended to be. But the Utah project that we're working on now, that's intended to be 400 megawatts, we are going to be really thinking about wellbore placement in a field context rather than just 2 wellbores next to one another. And because of that, I think wellbore placement is incredibly important because, we're looking at optimizing spacing in an entire section. And so you can't be willy-nilly, kind of what Clinton is talking about. You can't lose track of where your wellbores are because it could actually throw off the entire field design. So I do think that that's very important. For the audience, if you're not familiar with what we are doing, we're drilling pairs or triplets of horizontal wells, and then we are stimulating those wells to create, an orthogonal connection. So you can think about, you're drilling the wells like this, horizontal to one another, and then we're fracturing to create these pathways across the wellbore. And so the number one thing that's important for us in terms of well productivity and maximizing well output is actually the even distribution of flow across those wellbores. If you can imagine 2 horizontal wells next to one another, if you create, say, a really, really large fracture here at the heel of the well, and then the majority of your flow flows through that fracture, you can end up depleting the heat in that single fracture preferentially to the rest of the reservoir. And so what is incredibly important for Fervo Energy's design to be maximized is creating flow that's evenly distributed along that wellbore, because then we can produce a system that lasts for 30 or 40 years and sort of sustainably draws heat out of the reservoir in an even fashion. And so I would definitely say that's sort of the number one, technical design challenge that we're trying to overcome, is ensuring even distribution. Now, there are a lot of things in the oil and gas industry that you can do to ensure that distribution is well accounted for.
Okay, good. I guess a follow-up question to this discussion that's coming from the audience is cost. The cost of drilling wells. We're mostly talking about drilling horizontal wells. And are we going to be able to reduce the cost of drilling to the point where we can drill sort of doublets or multiple sets of wells, like you just mentioned? Or is a coaxial completion in a horizontal well going to be more cost effective? And what are the pros and cons and the arguments there? Yeah, Cindy, I'll let you take that one first.
Yeah, so our thoughts are, this is going to be kind of unconventional well revolution 2.0. Once you start scaling, you can do the multi-well pad drilling that the unconventionals has done for the last 15 years. And with scale, yes, you can drive costs down for these EGS systems. Our completion is a little bit different in that we are treating the fracture more like a balloon. We're operating that fracture in an open position. So as far as wellbore placement, that's going to be important for us, because as Sarah mentioned, there is a thermal decline aspect. And you've got to get these, at least for our well design, we've got to get these well bores at least 200 feet separated from each other, so you don't have any kind of thermal interference. But, with, again, existing oil and gas directional drilling equipment, we think that's going to be relatively easy. So again, our thoughts are scale up, with the scaling, the multi-well pad drilling, standardizing design, and of course, leveraging supply chain. Then yes, we're going to be able to drive down the cost of these wells, which in turn is going to help drive down the cost of geothermal. Now, one thing to mention, I know this is a drilling panel, but we're also looking at how to drive down the cost of the power plant as well. And there's an efficiency side. So how much electricity that you can get from the amount of heat that you're getting out of the ground is also going to be important to drive down the unit cost of that electricity. Or direct heating.
I'm glad you mentioned that, because there's a follow-up question about heat versus power that I'll come back to in a few minutes. So that's good segue for a little bit later on. Sam, any comments to add to that?
I think so. I would say what Sarah just mentioned about resource management, which is quite critical. I think Cindy also touched upon that. Is normally when we talk of people who have been drilling oil and gas wells, even myself, and have switched on to geothermal, oil and gas wells, we look at 3 to 5 years. I get maximum out of that well, and then that well is gone. I'm not worried about it. Whereas here, the most critical thing is the PPAs that we normally sign for for supplying power. They are normally 25-year PPAs minimum most of the time. That is quite critical, that what you produce from your well at the first day one or after you did your first flow test has to be sustained for the entire course of this 25 years. There are some times where we do well maintenance, but this is what it's generally expected to cost. So that again becomes quite critical. Is we have to keep that in mind, that resource, first finding the resource and then managing the resource is going to be very critical part of the techno-economic calculation, because that then ensures that yes, you are going to cut down the rate of costs, but at the same time you have to manage that cost over a period of 25 years. Thank you.
Thanks. So it's what I'm getting from that, and what I've got from just sort of kind of by osmosis from the industry over the last couple of years, is that kind of predictability and consistency is really important, because you're making investments that pay back over a long period of time, right?
And you always call it as base load power. So that is where it comes your main requirement as compared to other renewables.
Correct. Yeah, good point. So, okay, so Sarah, I'll throw that one back to you and let you comment a little bit about this.
Great. First off, also, I remember the second part of your question that I didn't answer last time.
Yes.
In the wells that we've drilled so far, to the audience member that asked that question, we are drilling through sedimentary to the basement, and then we're typically drilling our laterals in the basement.
Okay, thank you.
A little bit of cost reduction Fervo trivia, just to give you all an idea of what we're seeing in terms of learning curves. Across the 4 horizontal wells that we have drilled so far, it took us 55 days on the first well to reach 9,000 feet. When you think about, really that your costs are piling on a day-to-day basis, that's a pretty long time. It took us 48 days to reach 9,000 feet on our second well, 22 days to reach it on the third well, and 14 days to reach 9,000 feet on our fourth well. And so I do think that we're seeing a very similar learning curve in geothermal energy development when you can do sort of the basin drilling approach that we have seen in the Eagle Ford Shale and the Permian Basin and the Bakken as well. And so, when operators go into those basins, their first well is always really high cost. And then over time, they reduce that cost, by optimizing the reservoir, learning about the rock, many different types of things. We're seeing the exact same thing in geothermal energy. And so I do think that we are seeing massive cost reduction on a well-to-well basis. And there's a ton more juice to squeeze out of it at this point in time, even though we're, 14 days to 9,000 feet at this point.
That's great, and it'd be great to, as you said, it sounds just like an oil and gas development, the kind of curves you see over an oil and gas development project. Be interesting to overlay those kind of results over what you see from a typical oil and gas project, and then be able to kind of extrapolate, and then you get a bit more confidence in what the future state might be. Way back, part of the question was about the economics of multiple wells versus coaxial, or I guess multiple connected wells versus coaxial, to be more correct. Anything more to say about that part of the question?
Yeah, I mean, I think you can think about cost piling on based on a per foot drilled basis. And so when, you think about oil and gas development or geothermal energy development, it costs a lot of money to drill every foot. And so, I do think the most that you can minimize the footage drilled, the better. Now there's always an economic trade-off based on how productive your system is versus, how much you drill. And we are striving towards the optimal on that. We have found a really nice sweet spot where we can drill multiple wells and make these projects economic. And, we're seeing just better and better economics as we get better at building that system. And so from our perspective, multiple wells is no problem. But I do know that Cindy and her team have, discovered something different that's also working.
Okay, good. Thank you. And Clinton, any comments on that?
Yeah, well, as a service provider of the technology itself, I'm agnostic as to which technique, and I think all techniques should be encouraged, and and they all have merit. But speaking about the economics now, because my purview is mainly on closed loop, I want to tell a little quick story that should provide us all inspiration and hope. It's from our friends in oil and gas. So up in Canada, steam-assisted gravity drainage is a application that requires 2 wells be precisely placed apart. Survey management is very important. Lateral length is very important. Interestingly enough, Sarah, not having hot spots in your well where things can short circuit, and it doesn't allow you to realize the full economic benefit of the well. So when that whole industry started in Canada about 20 years ago, it required ranging and precision wellbore placement and all kinds of fancy drilling tools. And it used to take about 30 days to drill a pair of wells in Canada. Now it takes something like 7, 8 days. So it truly is a factory drilling process that involves, pad drilling, all these collision avoidance issues, magnetic ranging, survey management, wellbore positioning. And you can see that despite that complexity, which I don't expect to be any more complex, actually, in terms of a geothermal intersect, despite that complexity, the costs have been driven down by an order of magnitude. So that is a good roadmap, I think. It gives us hope. And, I believe, but discussions such as these, experience, like you said, Sarah, will just keep driving the economics in the direction that it needs to go.
And
It's
John,
another great example. Sorry.
yeah, sorry,
Go ahead.
if I may just segue real quick on Clinton's great example. The other thing that SAGD taught us is well design around heat cycling. So, cement design, casing connection design. So yeah, I like his example. I love his example because SAGD has taught us a lot around not only placement, but other aspects of wellbore design for geothermal.
Yeah, and it shows a similar story to between SAGD, unconventional oil and gas. The experience that Sarah is showing that Fervo is beginning to have is that you can dramatically bring down the time taken and therefore the cost of drilling wells once you get the experience and once you develop the techniques and the technologies.
Yeah, if I may,
go.
quick, John, I have to say this. At the time when SAGD started, literally people would say it cannot be done, it's not going to work, the economics, blah, blah, never, never, lots of negativity, right? And guess what? They're still up there chugging along today. And so it will be for geothermal. The same thing awaits us in the future, I believe.
That's brilliant. I couldn't have scripted that better because that's a great segue into the next question. And it's exactly the same as what people said to George Mitchell back in 2008 about drilling shale and extracting oil and gas from it. You're crazy. It's never going to work. And so it's kind of a segue into the next question. And I've heard a couple and this question came from the audience, and it's something that I kind of wish I'd thought of I would have asked myself if I'd have been in the audience, and so I'm glad it came up. We talked earlier about how heat is important, how temperature is important. I heard somebody say hotter is better, which is great because it was kind of a mantra that we at Hephae agree with. But I've also heard people saying that the tools we've got are fine, and it's okay to drill at between 175 and 200 Celsius, with cooling and stuff like that. If we kind of had our druthers, as they'd say in the northeast of the US, if we could like rub that sort of magic lamp and get our wishes, is there a place for deeper, hotter wells? And if so, what kind of technology breakthroughs would we need to make hotter wells, maybe sort of 250, 300 Celsius effective instead of confining ourselves to drilling at 200 Celsius? And Clinton, I'll keep you for that one, and then I'll pass it around to the others.
Yeah, sure. I'll take a shot at it. So once again, I just repeat what I've been told about hotter is better. Just remember, I just want to place the wells exactly where y'all want them. So that's been my focus. But look, a couple things. Do we have, let's say, directional drilling equipment right now that can deal with this? You can say technically yes, but hotter is not better for electronics. So let me explain. The higher you go typically with electronics, the lower your minimum time between failures becomes, right? So yes, you can get MWD, rotary steerable systems, etc., that let's just all agree operate at 175 degrees Celsius, okay? But if you run them at 175 degrees Celsius day after day after day, you will not expect to get the same minimum time between failures, the same amount of drilling before you have to trip to replace that tool as you would if you're drilling something more benign, like Midland shale well. So yes, we can drill the wells with the equipment is there, but that does not lend itself to efficiency in the long run, I don't believe. So pushing our technology even incrementally, if you get to 210, let's say, well, then you have a much more reliable system, presumably at 175. If you get to 225, you have a much more reliable system at 200, and on it goes. So I think that there is impetus, listening to operators that they want to drill hotter. And I think then we will have to make sure that the economics stay in lockstep. Excuse me, folks, adjust or improve our electronics and mechanical designs downhole.
Okay, that sounds good, and that kind of makes sense. And Sam, I'll throw it to you next, and then we'll talk to a couple of people who are kind of more on the operator side than the drilling side.
So I would say it's more also things like even drilling fluids. The moment you see your temperature going higher, all your drilling fluids that work at us, currently you've got normal drilling fluids and high temp additive. That's a better version of that. Now, the moment you start increasing temperature, as Clinton was mentioning, the additives also have to be modified to work in that higher temperature regime. Same thing applies to cement. Cementing these wells, the moment they are going to see higher temperatures, sometimes, if you have got losses while you're cementing and all, they see that higher temperature. The other big thing is when you talk of BOPs, the BOPs that we have, they've got rubber seals that are there. The moment you see higher temperatures, they are also going to be such that when you shut the well in, if they're not going to hold that, that's just very important, because if you're, for everybody, even in the audience, one of the only states in the country that uses that is Hawaii, because of a blowout that took place. There, we do not even use a 5,000 psi BOP. We use a 10,000 psi BOP, because that, if it is downgraded with temperature, is still able to close the well at 5,000 psi. So again,
Right.
well safety and HSE becomes quite critical. Thank you.
Okay, thanks. Cindy.
Yeah, for
If
me,
you had your
John.
way.
Yeah, well, and I'll have to just kind of turn the question back around. It comes back to techno-economic value. So I agree with everything Sam's saying. I would add to it, if you're running 95/8" casing even deeper, drilling rig capabilities for handling that type of hook load is going to be challenging. There's only going to be a few rigs around the world that can handle it. So not only, all the temperature and high temperature aspects that Sam mentioned, but it's, how are you going to case that well if you're so deep and there's not a drilling rig that can handle the hook load. But it comes back to techno-economic value, and it is a balance between the cost of drilling deeper and hotter is better as far as geothermal, but the cost of drilling deeper and the unit cost of the energy that you can get if you just target the 220 degrees C. Let's focus on those temperatures and drive the cost of the current tools that we have down, and the economics, the unit well economics down, like Fervo's doing, right? That's going to make the biggest difference.
So maybe what you're saying is drive the reliability of what the oil and gas, because even those temperatures are on the limit of what the oil and gas industry can achieve, right? So maybe drive the reliability of the oil and gas industry techniques and technologies up at around 200 C.
Correct, and the cost down. Yeah,
Cost
reliability
down,
up, cost down.
They kind of go in lockstep. Once you and they can move quite dramatically as well. So Sarah, if you had your wish, what technologies would you like to be able to get into deeper, hotter rock, or do you want to get into deeper, hotter rock?
Yeah, I think I probably don't have anything wildly brilliant to add in addition to what Cindy, Sam, and Clinton have already said. I agree with Clinton. Electronics are probably our biggest problem at the depths that we're currently drilling. The biggest thing that causes strain on casing and cement and everything that we are permanently installing down hole is delta temperature swings. And so we're putting cold, maybe not cold, but cool or at least warm water down, and then we're heating it up, and all of these components are seeing swings in temperature that cause pretty big strains on them. And so I think at what we have got going, we sort of are seeing the strains that the temperature or the equipment can currently handle. I'm going to do something risky here and give the obvious example of what Cindy's talking about in techno-economics. Obviously, it's not easy to drill offshore, and 100% of my background's onshore. This is why this is risky for me. It's not easy to drill offshore, but it was worth it, basically, worth it enough for us to adapt all of our approach to oil and gas development so that we could drill offshore. there is a techno-economic case for doing that. And I think in geothermal, we may see something similar. There is a reason to upgrade your casing, upgrade your cementing, upgrade your electronics, upgrade your BOP, upgrade simply everything in the operation in order to make it work. That's just not the business that Fervo is currently in.
Okay, I appreciate that.
John,
And,
if I may add one thing,
on.
thing is that what we have is, especially from what Cindy and Sarah and all are doing, we have been able to use the same thing what we used at Forge in an EGS project and applied the techno-economics and the advancements that we did. We transferred that to a commercial, conventional geothermal well, and we were able to sort of help that process in terms of number of days required to reduce it. So actually, it's a good learning curve, which can be applied also to conventional wells using the technology that we are now learning from EGS wells. Thank you.
Thank you. Okay, we have about 4 minutes left, and so we need to get into a final question. And there's an interesting questions come in, which is quite different from the questions we've been talking about, but I think it's quite relevant. And it's about transparency and data sharing. And we're all learning how to transfer technology into new applications, and we're learning about those new applications at the same time. And so it'd be really great if we could share all the data we have and learn collectively. But startups, and I can speak from personal experience here because Hephae is a startup, we don't necessarily like to share a lot of the data we've got for all sorts of good reasons, including some very good commercial reasons. So would you like to comment on that, and maybe just talk for 20-30 seconds each on that? And is there a solution that you can see that might make it easier for us to share? Cindy, I'll start with you.
Yeah, I'll just quickly mention what Project Interspace is doing around, geology, right? Having a common playing field for geology would be helpful for, the likes of Sage or Fervo or other geothermal companies. As far as data sharing between the companies, I think that can be useful. We're also doing slightly different technologies between the companies. So not directly competing, but sorry, I went over 30 seconds, but I think the project.
That's okay. It was a great shout out for what Project Interspace is doing.
Yeah, I mean, I think that's going to be a game changer.
A lot of people are going to appreciate that. Clinton, what do you think about transparency and data sharing?
Obviously there's a bunch of commercial issues and that kind of stuff, John. And if there's problems, people don't want to talk about it for obvious reasons. But I think, Society of Petroleum Engineers deals with that in a reasonable way. One way that I've participated in knowledge sharing is through the Industry Steering Committee on Wellbore Surveying Accuracy, which is an offshoot of SPE. And basically, all the survey, positioning, and ranging nerds like me get together and talk about this stuff, and we actually even put together a best practices, industry best practices on wellbore surveying and magnetic ranging, and that's available for anyone to download. For example, I would like to see something similar in geothermal. Perhaps that already is in place, but networking events, actual structured events where we get together over day-long sessions and share what we're willing to talk about our technology and applications.
That's a good point. Yeah, a role for learning societies, maybe like SPE or maybe like an equivalent of SPE, and there are many others as well. I know. Sarah, data sharing and transparency.
So we published a pretty detailed white paper after our commercial demonstration, and we got a lot of feedback from that. My mentor called me and he said, "What are you doing? You're telling everyone exactly what you're doing." And I said, "Yeah, I think the one-liner to that is you sort of have to embrace the first mover disadvantage here. We need a thriving
I thought that was great,
industry."
by the way, that you did that.
Oh, thank you. Yeah, we're we're a small industry, and in order to have it thrive, we need to help each other. And I think that it's important to all of us that we do have a thriving ecosystem, and to do that, sometimes you have to share what's going on.
Thank you. And Sam, we've got about 40 seconds left, so I'm going to
quick one. I think so. A very good example is drilling bits. What we have technology that we have learned, we are not sharing too much of data, but the drilling bit technology that has changed with our EGS and other type of wells that we're drilling now, that has been a good preceder to looking at drilling bit technology as an overall, where I would say in a very simple words, before drilling geothermal with PDC bit cannot happen. That was never in the books, and now that's happening. So as
Brilliant.
simple as that.
That's a very positive note to end on. So I'd like to thank all of the panelists today for their contributions. I'd like to thank the audience for their time, and I hope you enjoy the rest of Pivot.